So now we're going to look at how to multiply two vectors together, especially when we're working with algebraic vectors. So we're going to look at the dot product first, and there's a formula that's given in the content for the dot product that u dot v is the magnitude of u times the magnitude of v times cos of theta, where theta is the angle between u and v tail to tail. Now, the magnitude of u is a scalar or a number, so is the magnitude of v, and so is cos theta. So it's important to note that when I multiply these together, it gives me a scalar, not a product. So sometimes the dot product is also known as the scalar product of two vectors, because in the next section we'll look at a different product that gives us a vector as an answer instead of a scalar. But the dot product will give you a number. It has magnitude only, there's no direction. And u dot v is equal to v dot u. This is commutative, it doesn't matter the order, because it's going to be regular numbers, 2 times 3 times 0.5. It doesn't matter what order you do those in, it's going to give you the same answer. So let's look how to work with this. So find u dot v if the magnitude of u is 8 and the magnitude of v is 12 and the angle between them is 30. So not a big deal, we're just going to plug in the formula. So it's the magnitude of u multiplied by the magnitude of v multiplied by cos of 30. So that's going to be 8 times 12 times cos of 30. So you could go to your calculator and ask it what the cos of 30 is, but I hope 30 pops into your head as one of the special angles that you started working with in grade 11. And remember, in university next year, you may not have a calculator. So 30 degrees comes from our 1, 2, root 3 triangle. So the cos of 30 is root 3 over 2, adjacent over hypotenuse. And this angle down here in this corner would be 60 degrees. So 8 times 12 is 96. Then I have root 3 over 2. So that's going to give me 48 root 3. I did 96 divided by 2, and then I'm multiplying by root 3. So this is an exact answer. Just depending on what the question asks for, you could use decimals. Keep in mind, though, that you may not have access to a calculator, and that's the only way to do it. Again, I'm going to use the formula for example B. Now the magnitude of u is 13, the magnitude of v is 3, and now we're in radians, or our angle is pi by 4. Hopefully pi by 4 links to 45 degrees in your mind, or again a special triangle. It's our 1, 1, root 2 triangle, where both angles are 45 degrees, or pi by 4. But I'm going to start with my formula. I have 13 times 3 times cos of pi by 4. Well, 3 times 13, or 13 times 3, is 39. Cos of pi by 4 is 1 over root 2. Adjacent over hypotenuse, it doesn't matter what angle we look at because they're both 45 or pi by 4, which gives me 39 over root 2. Some will accept that as an answer, but some will say you're not allowed to leave roots on the bottom. So we rationalize this by multiplying by 1, made up of root 2 over root 2. So then I get 39 root 2 over 2. 39 times root 2 times root 2 is 2. So this has been rationalized, meaning now I have a rational number on the bottom, or a whole number, as opposed to the root of 2, which is a non-terminating, non-repeating decimal. Okay, number 2. Show that if the dot product gives 0, and u isn't the 0 vector, and v isn't the 0 vector, then u has to be perpendicular to v. So let's start with u dot v equals the magnitude of u times the magnitude of v cos theta. It's a formula. And we know that this is going to equal to 0. Well, if u is not the 0 vector, then it has some magnitude. So this is going to be some scalar, I'm going to call it a, times, again, if v is not the 0 vector, then it has to have some magnitude. So that's going to be a number. Cos theta equals 0. Well, a and b are both non-zero because u and v have to have some magnitude since we're told it's not the 0 vector. So if I get rid of them or bring them to the other side, I really end up with cos of theta equals 0. Now, if we think about that, you can ask your calculator, but a basic cos graph looks like that. And cos is 0 at 90 degrees or 270 degrees. Well, 90 degrees is the very definition of perpendicular. If the angle in between u and v is 90, then they're perpendicular. But what if the angle is 270? So there's my first vector. I'm going to go around 270 degrees. They're still perpendicular because it's the same as going back 90 degrees. So therefore, U and V are perpendicular if the dot product equals 0, as long as U and V aren't the 0 vector themselves. So those were geometric vectors because we were given the magnitude and angles between them. But we can also do dot product with algebraic vectors where we're given coordinates. And in the content, you were given a formula that U dot V is equal to the U, or the x coordinate of U times the x coordinate of V plus the y coordinate of U times the y coordinate of V. How that works is you simply multiply the x's together, and I'm going to show this. I would probably just write the answer. And then you're going to add multiplying the y's together. So negative 5 times 3 plus 2 times 4. So that's going to give me negative 15 plus 8, or negative 7. So now you can, I wouldn't show this step. I would probably just go negative 15, 8, add them together. This extends into 3 dimensions. But now the x's go together, so I get negative 2, plus the y's go together, that gives me 0, plus the z's go together, which gives me 32. So in this case, the dot product would end up being 30. So you multiply the corresponding coordinates, and you add your results together. So now we have 2 algebraic vectors, but we want to find theta, which is the angle between them. But we have a formula that involves theta. I have U dot V is equal to the magnitude of U times the magnitude of V times cos of theta. Well, U dot V I can find using what we just did by multiplying the coordinates and adding them together. So 6 times negative 1 is negative 6 plus negative 5 times 3 is negative 15. I'm thinking ahead to the answer. I can also find the magnitude of these. This is Pythagorean theorem, because remember, the magnitude of U is the x-coordinate squared plus the y-coordinate squared. So the x from U squared plus the y from U squared. So I'm going to kind of do this in my head. 6 squared is 36. 5 squared is 25. 36 plus 25 is 61. I'm going to do the same thing for V. 1 squared is 1. 3 squared is 9. 1 plus 9 is 10. And now I have cos theta. I'm going to add them on this side. So negative 6 and negative 15 gives me negative 21. And then I'm going to divide by root 61, root 10. And that gives me cos theta. And now to get theta, I'm going to ask my calculator. So I'm going to do negative 21 divided by root 61 and root 10. You may have to use equal signs or brackets. And then I'm going to second function coset to get my angle. So to grab my calculator. So I'm going to do negative 21 divided by bracket root 61 times root 10, close the bracket. And then I'm going to shift cos that answer, or inverse cos second cos, and I get 148 degrees. So the angle between U and V would be 148 degrees. That also works for 3-dimensionals. So we can't describe the direction of a 3-dimensional vector with one angle, but if I have 2 lines, even in 3-dimensional space, I can still figure out the angle between them if I think about them lying on a straight plane. So I'm going to do the exact same method I just did. Start with the formula for dot product. On this side, I'm going to find the dot product using our coordinates. So negative 15 and negative 4 and negative 2. I multiplied the x's, multiplied the y's, multiplied the z's. I'm going to find the magnitude of U, which is going to be 9 plus 1 plus 4, so root 14. I'm going to find the magnitude of V, which is going to be 25 plus 16 plus 1, which I think is root 42. And then I have cos theta. I'm going to figure this side out. Negative 15 and negative 4 and negative 2 is negative 21. You can get something other than negative 21 on that side. I'm going to divide by the root 14 and the root 42, which were my magnitudes of u and v. And now I'm going to use my calculator to find the second cos of that. So negative 21 divided by bracket, root 14 times root 42, close the bracket, and then shift cos, second cos, inverse cos, whatever it is on your calculator. So the angle between them is 150 degrees. So hopefully this shows you how to work with the formula. Any questions, be sure to email me.